Okay. Hello everyone and good morning. Today inshallah we will continue with our journey. I think today inshallah we will go through limits. I will try to cover today and tomorrow this part of the course which is related to limits in details. Then we will go through continuity, I believe, within next week inshallah. Okay, to start this part, mainly I will need you to understand the following. But before going further, I want you to go to Moodle. I usually upload all the lectures on Moodle periodically, so I think this part is already uploaded from the previous week. Also, you will have the recorded lectures on YouTube. I'm not really sure if I shared with you those slides or not. So please check on the WhatsApp. If not, just let me, remind me to share the PDF with you, okay? Okay, our today's agenda is gonna be, as you will see, we will introduce first limits from R to R, ya Omar, which is the main types, which it is mainly the main subject from Rn into or from R to R, yani functions in one variable. Then we will go through limits using a definition. This point I will delay a little bit till the end of our lecture today. Hopefully we will be able to go through this and the remaining will be continued tomorrow. But it's really very important to understand why we are using the definition. If we can evaluate the limits directly, why we have to use the definition. I will tell you. Limits of Rn into R using definition and using directed methods. Mainly, these are the topics that we are going to speak about today, inshallah. Okay, let me start with this sketch for these functions. And let's discuss, Mr. Ahmed, just leave your cell phone, please. Okay, and let's discuss the following limits. I want you to focus with me for a little while. بص كده يا عمر. Limits is usually find the value of f of x when x changes to reach certain value. So if you look, okay, carefully to this value, which is x naught, you will find the following: that the x-axis values are approaching x naught from both sides, from the left side and from the right side. Both of them are trying to reach x naught. The result, the value of the function by itself, it will try to reach certain value. Remark that this is the value of x naught that we are trying to reach, and this is the value that the function is trying to reach while we are trying to reach x naught. This is why you said we write the limit of x naught tends tends to x naught, which means the x-axis is changing, trying to approach this value. You will find the function f of x, which approaches to L or to y naught, as you can see from the graph. So once more, Yasin, when x changes from the left and from the right, look to the function. بص كده يا عمر, from the left, it's approaching certain value, and from the right, it's approaching the same value. Once x reach x naught, you will find the function is reaching y naught. That's the meaning of the limits. When the left hand limit, ya Ahmed, equal the right hand limit, when the limits are equal from the left and from the right, the limit exists. So the limit at x naught is y naught. Because from the left or from the right, the value is the same. If we tried to see the limit at x1, بص كده مستر عمر, for x1, بص, x is trying to reach x1 from the left and from the right. بص our function from the left and from the right. يبقى the value of the function is gonna be y1. Although y1 is not within your function. يعني although the function is not defined at x1, but you can find the limit, which represent as an upper bound or a bound for the function at this point. The key issue is when you take the limit from the left and you take the limit from the right, They are both equal to each other, and hence the limit will exist. Okay, if I try to get the limit of at x2, look at x2. بص يا أحمد, the limit from the right, the function is decreasing, incredibly decreasing. It's decreasing till it will reach negative infinity. معايا مسيو أحمد? And from the other direction, it is exactly the same. So from the left and from the right, the function is decreasing, and the both of them reaching negative infinity. So also, so also the limit exists and the function is negative infinity. معايا زياد؟ Okay, يبقى from the left, from the right. يا عمر, تعال بص على x tends to 0. While x tends to 0 from the right, the value of f will reach 0. بص الاكس بيتغير, الاف بتتغير. الاثنين بيساوي كام؟ 0. From the left. طب تعالى from the right, from the other side. بص كده اكس بتتغير، الفانكشن بتاعتك بتتغير، هتوصل لمين؟ توصل عند y2 لغايه y1 مثلا او y0. Are they equal to each other from the left and from the right? يبقى limit doesn't exist. Okay. This is really very important sketch showing you the various situations that the function may reach while you are studying limits, as you can see. We saw the limit may exist and the point of the function is within your range. The limit may exist although the value is not defined, like the negative infinity. The value may exist, the limits may exist, although the point doesn't belong to your domain. Okay? And also the cases when the limits doesn't exist. What you saw here is an explanation of the limits with functions in one variables, or from R to R يا عمر. Those are the famous relations relative to limits. If you look to those regulations, Mr. Ahmed, ده الادفانتج من انك خدت التوبولوجي. Leave your simple. بيقول consider the function f and g. يبقى how many functions do I have? Two functions, f and g, such that their domain, okay, is completely contained in Rn. يعني معناه ان الانترانس ممكن يبقى function several variables and the output is in R. يعني اللي هيخرج يخرج ايه؟ number 1. معايا يا شباب؟ بيكمل بيقول x belongs to the domain and a limit point of the if f and g have limit at a، يعني لهم limit exist according للكلام اللي شفته قبل كده. خلاص يبقى اذا الثيوريز دي هتبقى مظبوطه. اول ثيوري او اول معلومه عن الليميتس ان الليميت اوف x tends to a for a k، يعني لو الفانكشن بتاعتك بتساوي constant يبقى اذا value of the limit will equal to constant. طيب limit x tends to a at xi it is equal to a of I. لو انا في more than one dimension these are the values. الاكس دي ممكن تبقى x1 x2 x3. يعني لو انا في 2 dimension يا حسين البوينت دي تبقى 1 and 2 مثلا. I will make a substitution في الفانكشن تطلع value. طيب من اول 3 4 5 and 6 معايا زياد؟ 3 4 5 and 6 those four properties explain that the limit can be distributed on summation, on multiplication, on division. If you have a constant, it can be taken outside the limit sign. يبقى هنا بيديك advantage ان انا اقدر distribute الليمت على multiplication وديفيجن وخلافه. معايا مستر احمد؟ اوكي بيرفكت. هيجي تاني يقول لك الثيوري دي مهمه جدا. The limit of a function when exists it is unique. يعني لو انا عندي limit للفانكشن value for the function at x tends to certain value and it already exists, once it exists it's unique. You will never find more than value for the function when x tends to certain number. It's not gonna happen. Okay? Okay, direct limits and limits by definition. انا هتكلم على بعض الليميتس البسيطه. يعني مثلا ميسي عمر ده limit x tends to 2 هنا بيشرح لك limit x tends to 2 for the f of x. فين ال f of x؟ x plus 1 على x minus 3. All I have to do is just substitute. Okay, start substituting. Then you will have 2 plus 1 over 2 minus 3, which is negative 3. That's a defined value of a limit. Function is defined and the result is defined. Okay, if you look to this also, here is the explanation. We already did go through this, that once x is approaching from the left and from the right, those are y also will approach from x and y, and this is the value of your limit. Just an explanation. We already explained this in the previous slide. Now, for this function, مثلا, Mr. Yassin, Mr. Hussein and Asad, its limit xy tends to 1 and 1. In this case, I am moving from R2 into R. From R2 into R. معايا ياسين؟ يبقى أنا هشيل x يا حسين قصدي، هشيل كل x و y وأحط مكانهم 1 and 1. Make the substitution. هيجي لك 2 1 times 1 divided by 1 square plus 1 square, which is gonna be equal to 1. And that's also a direct substitution. If I went through this problem, I will discover the following you said. That this is gonna be replacing x by 0 and y by 0, you will have 0 over 0, which is an undefined quantity. معايا Mr. Muhammad? But you will remark that for this problem, I can simply analyze the difference between two squares on the denominator. لو أنا عملت كده أحمد يبقى عندي x minus y times x plus y. And hence, I can eliminate these two brackets together. And so the result will be x minus y. Now when you substitute, it makes sense. It's not a problem that the value of the limit equal to 0. So once you substitute, it's going to be 0 minus 0 over 1. So the result will be 0, as you can see. In a similar manner, computing the limit at 1 and 2 for a given function. This is also a function from R2 into R. From 2 dimension into 1 dimension. If I also make a substitution by 1 and 2, the result will be easily obtained and there is no problem with it. بصوا كده هبدأ replace every x by 1 and every y by 2, so you will have 1 plus whatever 2 over 2 minus 1 times 2, as you can see, regardless of the result, but it can be evaluated this thing. Unfortunately, we will face something like this. I need to evaluate the value of this function, which is, as you can see, running from R2 into R. The function اللي انت شايفه قدامك دي representing from R2 into R. The input, Mr. Muhammad, is 2 variables, which is x and y, while the output is just only 1 value. So I'm inserting 2 values, or the input is 2 variables, but the output is just only 1 variable. Okay? Also, when you substitute in this function, you will find there is no problem whatsoever. I'm just replacing x by 0, y by y, so it's a cosine 0, which is 1. Then you will have y equal to pi times e to the power of 0, which is 1. So the result will be 1 plus pi. There is no problem with this limit whatsoever. But Mr. Ahmad, if you look to this function, I need to find the limit of this function when x and y tends to the origin. Which means for this value or for this function, the plane will approach 0 and 0, the point 0 and 0. Let's substitute, Ahmed. If I make the substitution, replacing both x and y by zeros, you will end up having, yes, sine 0 over 0. And this is not defined, because it's going to be 0 over 0. But in this case, Ziyad, yes, you are right. If I substitute or make a variable, a change of variables, x squared plus y squared equal to z, to a certain value, when x and y tends to the origin, also if you put zeros here, it will lead to z equal to 0. Which means it's the limit of z equal to 0 for the function which is sine z over z, that's 0 by 0, and this is a very famous exercise which is gonna be equal to 1. So it's almost like a well-known result for this function. So I've succeeded in using the values of the famous limits, even if I'm running from R2 into R, as you can see. طيب ده شيء جميل. برضو same way like in evaluating limits, in evaluating these limits, let's continue. So for this problem also, as I told you, it's sine x squared y squared divided by x squared y squared. Once you let z equal to 0, for sine z over z, the result will be equal to positive 1, and that's a very famous example. Okay, let's look to this problem. I need to evaluate the limit also, Mr. Hussein, for x squared minus xy divided by root of x minus root of y. 50. أعمل إيه؟ ها؟ يبقى إذا, this is why I told you, you will have to use your pen. This is major. You can't study this part or the previous parts, Mr. Ziad, just looking at the video. As you do, you will have to use your pen. So, if I want to solve this problem, I will write limit. Limit of what? Of x and y, which are going to tend to zeros. معايا حسين? So, it's gonna be x squared minus xy divided by the root of x minus the root of y. Start substituting. It's gonna be 0 over 0. صح? Am I right? Okay. Now I will have to think. اتفضل.
وناخد x هايست الاول. وبعد كده هتبقى x minus y.
Okay.
هنعملها بقى difference between two squares. X
صح.
minus y و x plus y.
It's a difference between two squares. Yes, I can do that.
x plus y و root x plus root y و root x minus root y. root x minus root y هتشال
Yes, it's perfect. He tried to factorize, to take a common factor and try to factorize the denominator. Also, it's okay, understood? Okay. I can also multiply both the denominator and the denominator by the conjugate. This is also another card you can use. So I can simply, بص كده زياد, I can simply do it like this: x squared minus xy divided by the root of x minus the root of y times the root of x plus the root of y divided by the root of x plus root of y. From where this value came, it's simply trying to multiply by the conjugate of the denominator. Once you multiply by the conjugate of the denominator, what's going to happen? We will see the following. That's x times x minus y times root of x plus a root of y. زي ما يسمى بالظبط. Root x of root x is going to be x minus y. So instead of factorizing the denominator, I have multiplied by the conjugate. Okay? In this case, I can eliminate the zero factor from the denominator. Now I will deal with limit x and y tends to the origin for x times root of x plus root of y, which is going to equal to 0, as you can see. So I have no problem that the value of the limit will tend to 0. But how to handle it? The main issue is having a 0 in the denominator. ماشي شباب? Okay, perfect. Okay, جميل جدا. Continue. As I told you, now we will multiply by the conjugate of the denominator. Multiplying by the conjugate of the denominator will eliminate these two roots. Now I can simplify it by erasing x minus y, and the result will be exactly the same. So one-sided limits f from r to r. Once more, if you see this sketch which represent the how the values in the x-axis are approaching certain values, so I can write here limit x tends to -4 for f of x, and in this case while x is approaching -4 from both sides, the value of the function will also approach the value of 2, so the limit exists from the left and from the right. If I try to do so at x equal to 1, you will find that the limit of the function from the left doesn't equal the limit from the right. So the limit of x tends to 1, it's not gonna equal, it's not gonna exist. زي ما شايف Mr. Ziyad, if I'm trying to approach x at 6, the value of the function is given by 2. Okay, so the function is defined and the value is equal to 2. But if I'm trying to evaluate the limit, ya Muhammad, you will remark that the value of the function is approaching another value, which means 5. Although 5 is not defined, it's not within your range. Do you understand what I'm saying? So although the function is not defined or the value is not in your range, but it is an accumulation point, so now I can find the limit. And in this case, as we will know down the road, the function is not continuous. Because the value of the function is equal to 2, while the value of the limit is equal to 5, as you can see from this. So there is no continuity at this point, although the limit exists. In this part, it is not continuous, as the limit doesn't exist. In this part, it is continuous, although also the function is not defined at this value. برضو, a similar debate for all of these points already exist in here. So here's the result. If you are trying to see at 4 how is the situation, the function limit exists. If it is at positive 1 from the left or from the right, they are not going to equal to each other. And if x approaches is 6 from the left or the right, the function exists and the value is equal to 5. Now, a limit of a function when exists, as I told you, it is unique. This is how functions are moving along just only one direction, from the left and from the right. And as we already explained in the previous slides, that if the function from both sides, right side or by the left side, they are equal to each other, it's a necessary condition for the function value to exist, as you can see. زياد, you said, سيب لي فيه خالص. Now مش عايزك تبقى معايا. محمد اقعد. Okay, if you look to R2, لو بصيت على R2, الكيسز اللي explained دي, it was in R1. It's coming from the left, coming from the right, you just only have one bus. But the problem is, once you deal with more than one variable, like this problem, yeah, you said, if I am in R2 and I need to approach this point, I can approach it from infinite number of buses. So I can approach this point according to this function, or according to that function, or according to that line, or depending on this line. So the number of buses around this point, it is infinite. It is infinite. That's a great problem for evaluating or for approaching the limit in multivariable functions. Okay? So once more, how can we approach the point A and B? There is an infinite number of buses to the point A and B. It is completely explained in here. That's a huge problem. Also, this will give us the following. Because we have an infinite number of buses, we cannot compute the limit of the function along all the possible buses. If you try to evaluate the limit through 2 buses, 3 buses, 4 buses, 5 buses, 100 buses, you are not sure that all the buses will give you the same result. صح? And this is why it's a little bit complicated in evaluating the value of a limit in case of multivariable functions. So this is not a way of proving the limit exists, but it is a way of proving that the limit doesn't exist. If I want to show that the limit at certain point doesn't exist, I will use different buses. And if all of them is equal to a certain value, it is not confirmed yet that this function or this limit exists. But I will have a hunch, or I can speculate that the function value is equal to that number or to this value. How to be sure? I will go through the definition. This is why the definition is very important to understand, and you will see it. You will go through a proof. That's why or how the function limit will exist. Okay? Okay, once more, limits of a function f from R2 into R. When investigating whether a function has a limit at a point or no restriction, it's exactly the same, but I wanted to explain it more, so this is the point that we are trying to approach, and you have, as you can see, that's a curve, that's another curve, that's a third curve, and each one of them will have different values. I can use general lines. Limit t tends to 0 of an f of a plus ty. That's the straight lines that will pass through a certain point. أنا محتاج تركز قوي. كل اللي فات ده أنت عارفه. أيوه. Okay. بس الجديد ده لأ. So in R2, a general equation of a non-vertical straight line is going to be y equal to m of x minus a plus b. That's when you are dealing with a and b. Now I have some paths with me. I will need to check them. The first method is called the direction limit, or the directional limits, in which I will try to evaluate the value of the limit using various paths, يعني various lines, and I will see what's gonna be there, either lines or curves or whatever. So let's do it step by step. Let's take this example let's take this proper example. Yeah. I need to see the limit or to get the limit of this function while xy tends to the origin. يبقى أنا حاليا عايز أعمل إيه مستر زياد؟ طبعا القلم بتاعي معايا، أنا كل اللي أنا عايز أعمله عايز أجيب الليمت بتاعت xy tends to the origin for which function 2xy divided by شباب x square plus y square, which is simply, once you substitute, you will find that the value is 0 over 0, which is undefined. Am I right? Okay, I will try to go through it step by step. Let's try one of the simplest curves by the idea. That's the shape of this function in front of you. If I want to try x equal the x-axis, for example, so, or the y-axis. If I want to evaluate this function at the path or approaching 0, and I approach 0, that's the origin. I want to approach it through x equal to 0. X equal to 0, it means this line, which is the y-axis. The equation of the y-axis is x is equal to 0. طيب أعمل إيه؟ بص كده يا زياد، هعمل الليمت بس actual أنا هستخدم y equal to، أو خليني الأول استخدم y equal to x. مني بس ماشي بالترتيب ده. أنا هروح برضو الإكس أكسس كمان شوية. بس أنا هستخدم مين على طول؟ أول واحد y equal to x. بص هعمل إيه كده؟ ده y equal to x. So I'm trying to approach from the plan, the origin, by y equal to x. Okay, so it's gonna be y equal to x. That's the path that I'm going to use. Which means I can use a substitution. Every y I will replace it with x. So it's gonna be 2 over an x squared divided by x squared plus x squared. That's the limit of y tends to 0 when y is equal to x, as you can see. I'm sorry, x is equal to 0. So it's gonna be 2 over an x squared by 2x squared. That's the limit of x tends to 0, which is gonna equal to positive 1. So if I tried to approach the origin using the line y is equal to 0, the result يا محمد طلع بكام؟ 1. طيب, what if I tried to reach the origin by the y-axis? What's the equation of the y-axis? بص كده ادي limit of x and y 0 and 0 for the function 2 over xy divided by x squared plus y squared. But in this case, I will use the y, I will move through the y. So يبقى أنا همشي على الواي axis. هحاول to approach the origin is on the y axis. Which equation is x equal to 0. Once you do so, you will have 2 times 0 times y divided by 0 plus y squared, which will result by on 0 divided by y squared, which means the limit is equal to 0. I've tried through the y-axis, the limit is equal to 0. I've tried through y equal to x squared, the limit is equal to positive 1. Like, what if I tried to do exactly the same, this is x and y, using the line y equal to 0. In this case, I will approach the origin, but using the x-axis. I will move through the line of the x-axis. If I am trying to use y equal to 0, also, or this pass for 2xy divided by x squared plus y squared, the result will be, try to substitute, so it's going to be 2x times 0 divided by x squared plus a 0, so the result will be 2 divided by 0 divided by x squared, which is also 0. From these two functions, or from these two bosses, they are equal to each other. So the x-axis, y-axis, equal to each other. But if you use y is equal to x, it's not equal to both of them. طيب يا زياد, what if I used a general equation of a line passing through the origin? زي مين؟ زي ده كده, بص كده, بص y equal to mx. Y equal to mx, it means y equal to 2x, y equal to x, y equal to 3x, whatever. Or even in the negative side. And all of them are lines from anywhere in the domain approaching also the origin. تعالى Mr. Muhammad كده نعمل substitution. And this is x and y tends to the origin. So once you try to do this, the function value will be 2 over x times mx divided by x squared plus m squared x squared, which is simply, شباب, this is limit x and y reaching to the origin, and this is y equal to mx as a line, and it's gonna be 2 over x squared m divided by x squared 1 plus m squared. So just eliminating x squared from the denominator and the denominator will leave you with 2m divided by 1 plus m squared, as you can see. So from this case, the limit of this function at the origin, يا Mr. Ahmed, it doesn't exist. طب أنا عرفت منين إنها doesn't exist? As you can see, the value is not equal. From y equal to x is not equal to y equal to 0 or x equal to 0, or the general case of y equal to m of x, as you can see. From all of this, the limit can't exist. And that's a very important, really very important example that showed you that although the value of the limit at some passes may equal to each other, but if there is just only one pass that doesn't share the same value, it means that the function limit doesn't exist, as you can see. So once more, here is the trial. When y is equal to x, I will make a replacement Ahmed by replacing every y by x. So it's gonna be 2 over x squared divided by x squared, as you can see. I can simplify it so the limit is equal to 1. Once more, Ziad, if I use the line x equal to 0 or y equal to 0, which means x equal to 0, yes, you are right, the y-axis. Okay, or y equal to 0, the x-axis, okay? And if you try to do so, this is the x-axis, y-axis. So I'm trying to approach from both sides. Once the bus of the x and once the bus of y. And similar results will happen. Once you make the substitution, بص شوف هو بيعمل ايه؟ بيشيل الاكس ويشتغل على الزيرو بيستخدم السبستيتيوشن اوف ذيس ايكويشن. كانت الريزلت بتاعتي بتساوي زيرو. زيرو اوفر واي سكوير which is zero. Also in a similar manner if I used y equal to m of x and make the substitution, you will find that the value of the limit will depend on the slope of the straight line. As you can see, approaching the origin from more than one direction, it's different. So the limit doesn't exist. The limit of this function at the origin doesn't exist. Okay, so since there is two limits not equal than this limit, then it doesn't exist near the origin. أنا يكفيني كم حاجة مستر زياد؟ 2. طب اصبر تعال نشوف بروبلم تاني. هنا بيقول limits along non-linear paths. What if I solved the previous problem or a problem similar to it, which is 2x squared y divided by x power 4 plus y squared. I'm trying to approach the origin. Okay, I'm trying to approach the origin, but using the non-linear curve y equal to x squared. Mr. Ahmed, أعمل إيه؟
عامل اكس واي ايكوال اكس.
ها؟ يبقى إذا y بيساوي x squared. These are the values once x or y trying to approach the zero. This is the value of the function, and now I'm using y equal to x squared. صح مسيو محمد؟ طيب start substituting by x squared. يبقى this is gonna be 2 over x to the power of 4 divided by x power 4 times x to the power of 4. Adding them together will leave you with 2x power 4 divided by 2x power 4, so the limit is equal to 1. Am I right? So it's another way, خلي بالك. It's another way to reach the same point, which is the origin, صح؟ Okay, اتفضل.
عندي سؤال بعدين فاينل انسر يكون 1 ولا يكون 0 0 ده المسألة اللي فاتت.
There is no final answer. المسألة اللي فاتت ما كانش فيه limit. لأنك لما جيت تمشي على كل كيرف من الكيرفز ده مش نفس الفاليو. طب تعال نجرب في دي كده، بص كده. دي 2x cube of what؟ يعني مثلا استنى. بص I've tried to check a bus reaching the origin، يعني أنا بحاول من البلان إن أنا teach the origin for this function. طيب let's try y equal to x. لو أنا حبيت أجرب y equal to x. لو أنا جيت أجرب y equal to x علشان to approach الليمت y equal to x هنا واعمل substitution، بص الفانكشنز ايه اللي هيحصل او الفاليوز ايه اللي هتحصل. لو جيت اعمل كده هيدي لك 2 over x cube divided by x to the power of 4 صح؟